Well, the other day I had a project and I needed to have 1 4/5 of a foot of a board to do a project with. And out in my backyard I had a 3 1/2 foot board. So I decided to find out how much board I would have left over if I cut off 1 4/5 of the board. How much would I have left? So the first thing I did was I set it up like this, up and down, not sideways. And you'll see why I set it up and down, because I have halves and I have fifths, and I can't subtract halves and fifths, and so I need a common denominator. I need the right tool. I need a common denominator. And so I need the same number under this fraction bar as under this fraction bar, not halves and fifths. The way I find that is I do the multiples of 2. I go 2, 4, 6, 8, 10, 12. Let's see if that's enough. Now I go the multiples of 5. 5, 10. Uh-oh, look at that. I've got a common multiple. 10 is in both of them. There's nothing else in both of them, and that's the least common multiple, and so that's my least common denominator. That is what goes there, and that's what goes there. Now, I've got to figure out what goes up here. And I know that it's going to be this numerator times something, but I don't know what. I don't know times what. And so the way to find out times what is to go 2 times something is 10. Ah, I know that one. 2 times, look at this, 2 times 1, 2, 3, 4, 5 is 10. 2 times 5 is 10. And now I know what to multiply this one by. This numerator here gets multiplied also by 5. 1 times 5, I got this, is 5. I'm really good at my ones. And now I know what we got there. I've got 5/10. Yeah, all right. And I still have this 3 over here. This is a whole number, 3 5/10, minus 1 and some number of tenths here. So let's follow the same procedure. I know that I have to have 4 times something, and that's going to be my numerator, but I don't know what it is. To find out what I'm going to multiply 4 by, I got to say 5 times what is 10? Well, look at that. 5 times 1, 2 is 10. 5 times 2 is 10. Now, I just multiply the 4 times the same thing, 2. And again, why that's legal is that 2 over 2 is 1 whole. And if I multiply something times a whole, it stays the same. Same thing up here. 5/5 is a whole. So 5/10 is the same as 1/2. All right, so 4 times 2, 4 times 2, I just happen to know, is 8. So now I have 5/10 minus 8/10. Actually, I have 3 5/10 minus 1 8/10. And when I'm subtracting or adding fractions with the like denominator, with the same denominator, I just add or subtract the numerators. Well, I can't go 5 minus 10. That's not in one of the things that I can do when I'm working with these boards. I can't go 5 minus 8. I can't do it. So I have to borrow. Now when I borrow, I can't just put a 1 here like I do in regular things when I'm borrowing things. I need to borrow from this 3. So I'm going to borrow from the 3 and make it a 2. Borrowing 1 whole from that. And I just can't put a 1 there. I have to borrow that 1 whole in terms of, and I'm going to add that to this 5/10. I have to borrow that 1 in terms of tenths. So I know that 10 tenths is a whole. And so I borrowed that 1 whole. I turned it into tenths, 10 tenths. 5/10 plus 10 tenths equals 15 tenths. Now I can subtract. See, I couldn't subtract 8 from 5, but I can subtract 8 from 15. So now I can go 15 minus 8. 15 minus 8, I believe, is 5 minus 8. No, we can't. We just got to go 8 to 15, and that's 7. So my answer is 7 tenths for this part, but I can't forget about these whole numbers over here. I still have 2 here and 1 there, and 2 minus 1. I am really good at 2 minus 1, and that is 1. And my answer is 1 and 7 tenths. Very exciting. I have 1 and 7 tenths of a 1 and 7 tenths feet of board that's going to be left over after I cut off the 1 and 4/5, minus some sawdust or something. Ah, but wait, there's more. There's still another way I could have done this. I could have said, I know that 3 1/2, this 1/2, all fractions are also division problems, and I could find out what that works out to as a decimal. And so I could go 1 divided by 2. That's 1 divided by 2. And put a decimal right there, and that decimal comes right up to the top. And I could say, all right, 2 doesn't go into 1, and so there's a 0 up there. But 2 does go into 10. 2 goes into 10. 2 times something is 10, and it's 2 times something is exactly 2 times what is 10? 2 times 5 is 10, and 2 times 5 is exactly 10. I subtract and I got nothing. So 1/2 is 1 divided by 2, which is also 5 tenths. That's how we say 0.5, 5 tenths. Pretty cool. All right, so now I can do the same thing with the 4/5. That's the same as 4 divided by 5. So we go 4 divided by 5. And 5 doesn't go into 4. And so that's nothing there. And we have a decimal there. And we can add a 0 there just because that's legal to add as many. We could add zeros till the cows come home out here, and it doesn't hurt that 4 at all. So 5 doesn't go into 4, but 5 does go into 40, and 5 goes into 40. 5 times something is 40. 5 times 8 is exactly 40. And 40 minus 40 is nothing. So I know that 4/5 is the same as 8 tenths. That makes sense. 4/5 is the same as 8 tenths. Yeah? And that's how we say 0.8, 8 tenths. Now that I have done that, I can say 3, that's my whole number over here, and 5/10, or 3.5, minus 1, there's my 1.8 is, can't go 5 minus 8, so I got to borrow from here, make it a 2. Now I have 15 minus 8, and it's a 7. And 15 minus 8 is 7. 2 minus 1, I got that. And 2 minus 1 is 1. So my answer is 1 7/10. 1 7/10, 1.7. And remember what my answer was over here? It was 1 7/10. Yay! The crowd goes wild! Yeah.